This conference will now be recorded.
Hello everyone. So here we will discuss previous year's questions from NEET exam, and that is from the chapter Thermodynamics. We have the first question, the equilibrium concentration of the species in the reaction which is given as A plus B in equilibrium with C plus D. And here the concentrations are given as 2, 3, 10 and 6 moles per liter respectively. That means 2 for A, 3 for B, 10 for C and 6 for D. So this is the equilibrium concentration of these reactants and products. Both are given in the unit moles per liter. Temperature given 300 Kelvin. We have to find del G naught for the reaction. And also the R value is given as 2 calorie per mole and per Kelvin. All the answers that you can see, they are also in the calorie unit. That means the calculation should be in calorie per mole per Kelvin. So that is why the R value is given in calorie unit, because if it is in SI unit, it will be 8.314, but that value is not given. Now, how del G is related to K equilibrium, that is the equilibrium constant, that formula we will require. But before that, we have to find what is the K equilibrium value for this reaction A plus B producing C plus D. So we'll just put all the concentrations, as you can see here, all these 4 concentrations are given, and that we will put in the expression of K equilibrium. Now K equilibrium, that will be concentration of C multiplied by concentration of D, and there is no coefficient, so it will be simple A and B. Now if you put all these, you will get the value of K equilibrium. Now the next step is to write the relation between del G naught and K equilibrium, which is minus RT ln Q. Sorry, RT ln K equilibrium. So this is the relationship. Del G naught is equal to minus 2.303 is written because we have converted ln to log. Without 2.303, it will be minus RT ln K equilibrium. So here we have this value. You can also calculate it before, or directly you can put it here. 10 into 6 C and D concentration 2 and 3. So putting all the values, because all are given. R value is given, which is in calorie per mole per Kelvin. T is given, which is 300. So putting 2, 300, and after the final calculation, we are getting the result as minus 1381.8 calorie, and which is matching with the second option. Okay, so this will be the correct option. We'll go to the next question. Which amongst the following options is the correct relation between change in enthalpy and change in internal energy? So change in enthalpy is del H and change in internal energy is del U, right? Now H, how it is related to U, that we have to know. Now H is equal to U plus PV. But when we consider del value, we can write the equation as del H is equal to del U plus P del V. Fine. But here you cannot see in any of these options, there is no mention of P and V. There is only mention of N and R. That is except H and U. So PV equal to nRT, that relationship we know for ideal gas equation, right? Now this N, as it is P del V, so N value we will write it as P del V, that should be equal to del N. Here as subscript I will write G. Now what is the meaning of G? G means total number of gaseous moles difference. So in the product side there will be some production of number of moles. So suppose I am writing in general, I have a gaseous reactant which is, we have taken it as 2 moles and it is producing 3 moles of another gaseous product which is B. So in this case, the del Ng value should be 3 minus 2. That is the difference. Final total number of gaseous moles and minus total number of moles, gaseous molecules obviously, in the before the reaction. So here del Ng value is 3 minus 2. So this is the meaning of del Ng. So in place of P del V, now you can put. So this is the relationship between del H and del LV. That is the change in enthalpy and change in internal energy, and that you can find in the first option. And why the other options are not correct? Because in the other options, in the second option, in that N, here it is, there is no mention of G as subscript. So it seems as if it is simply the number of difference in the moles of product side and reactant side. Whatever is the state of the physical state of the reactant or product, but it is only for gaseous. So that is why G subscript must be there. And even if you put G, then also it is not correct, because when you bring del U in the right hand side, still there is a negative sign. So this is not correct. This one is not correct. There is no T. This is absolutely not correct. Then the last one, it is fine, but here sign is wrong. So first option will be the correct option. Okay. Next question is 1 mole of an ideal gas, 300 Kelvin, expanded isothermally. So it is isothermal expansion from 1 liter to 10 liter. Del U value we have to find. R value is given 8.314. But remember, it is isothermal process, and for isothermal process, del U is always 0. So this is very important term in this whole question. If you miss this isothermal, then it will be wrong. You will do some calculation, but here we don't have to do any calculation. Simply it will be 0 because it is isothermal condition. The expansion is occurring. So correct option will be option A. Which of the following PV curve represent maximum work done? Now here we have PV curve. That means P, it is in y-axis, V is in x-axis, and that is true for all the 4 options, all the 4 graphs that you can see here. Now when we talk about maximum work done in PV curve, that is actually the area of PV curve, because when it is PV work done, that is work done in terms of change in volume, then P del V that we consider, which is nothing but the area under PV curve. So the area, whatever you will get, that area is actually the maximum work done. So looking at the graphs, you just have to find in which case the area is maximum. Here no values of pressure or volume are given. Just from the picture we have to understand it. Now in the first case, if you consider the PV area, this is the area. Now in the second case, it is simply a straight line which is fixed at this point. That means here pressure is changing. Pressure is in y-axis. So pressure is gradually increasing, but volume is fixed only at one point. So here nothing is actually happening. No expansion is happening. So area is not possible. So this is absolutely not correct answer. Then we have the third option, where if you consider this area, obviously this area is lesser than the first area, isn't it? First area, easily we can understand the area is larger compared to 3, and even it is larger from this area. Now this is a cyclic process. Cyclic process means suppose you have started from this point, now you are moving clockwise and you are reaching at the same point, whatever point you can choose. But whether it is cyclic or not, that is not important. Important point is you just have to consider the area, and this area is lesser than the area which we can get in option 1. So that is why option 1 should be the correct option. Maximum work done possible in this case. For irreversible expansion of ideal gas under isothermal condition. So here we have some conditions mentioned that we have to understand. First of all, it is irreversible. Then it is expansion. Then it is isothermal condition. Okay. Now, as we know, just 2 slides before, one problem we have seen where it is asking to calculate the internal energy change, which is the del U value. Now for isothermal, it is always 0. So del U will be 0. And that you can get in option A, option B, option C. Only in option D it is not 0. So it is not possible. Now ABC, how to choose which one is correct? Sorry, by mistake I have mentioned these two as both are same actually. So there must be some difference, but we still have the correct answer with us. So del U is 0, but what about the change in entropy? Now it is expansion. That means entropy will be positive for the surroundings. that is total value, total entropy, because here it is mentioned as total. So total entropy, it has to be positive, right? So for spontaneous process, it is always positive, and since it is irreversible process, not just expansion, it is irreversible process. So which is always spontaneous, irreversible, always spontaneous. So that is why this term is also important here, irreversible. Because if it is mentioned as reversible, it will not be the same answer. So it is irreversible process which is always spontaneous, and that is why this has to be positive. But positive del S is not written, it is simply written as not equal to 0, which also means that is, it may be positive or negative. But as we have in the option only that, so that is why we will choose the first option. Okay. For the reaction 2Cl, 2 chlorine atom, gaseous condition, you are getting chlorine, diatomic chlorine gas. So here Cl, that means 2 chlorine atom. From 2 chlorine atom, we are getting 1 chlorine molecule, right? So this reaction, for this reaction, we have to choose the correct option. In the options, we have del RH and del S. Now R signifies reaction. So enthalpy change for the reaction and entropy change for the reaction. So whether it is positive or negative, that actually we have to find the correct combination. In this case, you are basically making a bond. You are making a new bond between 2 chlorine atoms. And whenever there is bond formation, the process is exothermic. So there will be release of energy. Suppose if you consider the reverse reaction where you are breaking the molecule bond between 2 chlorine atoms and you are getting 2 chlorine individual atoms. In that case, it is energy requiring process. So you have to provide energy. But now you are making a new bond between 2 chlorine atoms. So that is why energy will be released. So it will be releasing energy and it will be exothermic. Now exothermic, that is del H less than 1, that you can get in these two options. Now what about the S value? So in this case, from 2 chlorine atom, both are gaseous, we are getting a single molecule, right? So if we consider the total, just before giving the explanation, I have already chosen the answer, but why it is less than 0? The actual logic behind it is that here 2 individual atom you have started with, but now you are getting only a single molecule. That means, and all are gaseous. So if you consider the number of moles gaseous, it is 1, it is 2. So here del Ng value, that is actually negative. And when del Ng value is negative, you have to consider it that entropy is negative. So that is why both are negative, that will be the correct option. Okay. Which of the following is correct option for free expansion of an ideal gas under adiabatic condition? So here we have to focus on these terms. It is free expansion, it is ideal gas, and it is adiabatic condition. So these two terms will help us to answer the question. First of all, when it is free expansion, that means we are not putting any pressure. It is just a free condition and expansion is occurring very naturally. So in this case, remember, work done is always 0 because you are not doing any work, it is occurring freely. So the system is not doing any work. Okay, so it will be considered as 0. Now W equal to 0, that you can get in first 3 options. Now what to do next? It is also mentioned that adiabatic condition. Now adiabatic condition means Q will also be 0. Now both are 0. That also you can get in option 1, option 3. But you also have to know what about the del T. Now del T, if you somehow know internal energy change, whether it is 0 or not, then also you can get you can get idea about the process whether it is isothermal or not. So from first law of thermodynamics, we get the relationship between del U, W and Q. So when these two are 0, basically del U is also 0. Del U 0 means it is isothermal process, and isothermal process means what? There is no change in temperature. So whatever is your final temperature T2, and whatever is your initial temperature T1, both are actually same. So that is why it is isothermal, and del T will be also 0. So considering all this, we can get the answer, which is option 3. So here you can see the logic. As it is free expansion, there is no pressure applied, external pressure is 0. So W is always 0. Next thing is it is adiabatic. So Q is also 0. The third step is it is first law of thermodynamics that you have to next apply. So because now you can get the value of del U, which is required to decide whether the process is isothermal or not. So now you can finally say that del T is 0 because del U is 0. So in this way, stepwise we have to consider. First, W 0. Second step is Q is 0. Third step is del U is also 0. Now del U 0 means del T is also 0. So option 3 should be the correct option. Okay. For a given reaction, del H value is given, which is 35.5 kilojoule per mole. Del S value is given 83.6 joule per Kelvin per mole. Be very careful about the unit. It is in kilojoule, it is in joule. Mostly you will see del S is given in joule because the values are so, but del H is given in kilojoule. The reaction is spontaneous at which temperature? That is the question. And within bracket, there is a information given. Assume that del H, del S do not vary with temperature. Now we have to find that temperature where it is spontaneous. Now for spontaneity to decide, we have to know. We need the relation, we need the sign of del G, whether it is negative or not. Now del G directly the value is not given. You just have the value of del H and del S. And we know the relationship of del H, del G and del S. So this is the relationship. Now for this process to be spontaneous, del G, that has to be negative, right? Now, if it is negative, then how we will do the calculation? That we have to understand. So as it is negative, that is del G is negative. So this total term, that is also less than 0, right? Because this term is less than 0. So this term is also less than 0. Now, if it is less than 0, and now if you bring any of this term to this side, suppose I am writing here del H, T del S. Now you can see T, it is del H divided by del S. That means T must be greater than this value, this ratio. And this you can easily calculate because these two values are given. So del H value is 35.5, but that is multiplied by 1000. Why that is multiplied by 1000? Because it is given in kilojoule. So we are just converting it to joule. And then we have the value of del S, which is directly given in kilojoule. So that is why, directly given in joule. So that is why it is 83.6. We have not changed. And you can also do the reverse process. That is, you can keep 35.5 as it is, and you can multiply with 83.6 10 to the power minus 3. But that will also do the same thing. What I am saying is, suppose you have written del H value in kilojoule unit, and you are converting del S value to kilojoule unit. But that also means the same thing, because ultimately it will be now 10 to the power 3, right? So after doing finding this ratio, which is 424.6, nearest value is 425, because in the options it is given as 425. There is no decimal, but it has to be greater than. Be very careful whether it is greater than or less than, because the question is asking the reaction is spontaneous at which temperature? Is it T greater than 425 or is it T less than 425? So just because that is just getting this answer is not enough. Suppose you have done the calculation correct 425, but that is not enough. Whether it is greater than or less than, that we have to understand. So that is for that here this calculation we have to do properly. So first answer should be the correct answer. A gas is allowed to expand in a well-insulated container against a constant external pressure of 2.5 atmosphere. From initial volume 2.5, the final volume is 4.5 liter. The change in internal energy, that is del U, of this gas, you have to find in joule unit. So see here, external pressure, that is Px is given, final volume is given, initial volume is given, but these two volumes are given in liter and P external is given is at ATM unit. So when you will do the calculation for a del U, you have to also change the unit from liter atmosphere to joule. Okay. Now it is well insulated container. It means what? This is the important information. Well insulated means heat cannot pass. That means it is adiabatic process. And when it is adiabatic process, how to calculate del U? Now del U is directly equal to W because this part is 0. Now if it is directly equal to W and W, how to calculate? You know the P external, you know initial volume, you know final volume. It will be simply P del V. So del U is equal to W and it is minus P del V because it is expansion work. So system is doing the work. So that is the reason it will be negative. Okay. So sign is also very important because even if you are reaching the correct answer, maybe for sign also there may be two options. So you have to select it properly. So P value is 2.5 atmosphere. This is the final volume. This is the initial volume. And you are getting 2.5 into 2. Okay. So 2.5 into 2, which is 5. But we are converting it to joule, and that is why we are multiplying it with 101.3. So 1 liter atmosphere. 1 liter atmosphere, when you are trying to convert to joule, then you have to multiply it with 101.3. So that is why the final result is 506.5. And if we take the nearest value, because it is not given in that, so 505 you have to consider. But be very careful about the sign because 505 is given in with both signs, minus, plus. So just correct calculation is not enough. You also have to understand the sign. So this should be the correct option. We'll go to the next question. For a sample of perfect gas, when its pressure is changed isothermally from the value Pi to Pf, then the change in entropy. So change in entropy, how it is related to Pf and Pi, that relationship is given in options A, B, C, D. Try to understand difference. Here it is Nr, Ln, Pf, Pi. Nr, Ln, Pi, Pf. Now these two are, their positions are changed. This is Nrt. This is Rt only. There is no mention of N. And Ln, Pf, Pi, these parts are more or less same. Only sometimes these two are changing their positions. Now we will try to see that del S, when there is two different pressure and then there is some process occurring, then what is the relationship? Now first of all, even if you consider that for some time, just consider that it is not isothermal and undergoing reversible expansion, then the temperature changing from Ti to Tf, initial to final, Pi to Pf, then what is the relationship? Then the relationship is like this: NCP ln Tf by Ti, Nr ln Pi by Pf. But in this case, as these two are same, so this part will be 0, and ultimately what we will get? We will get only this part, which is Nr ln Pi divided by Pf. So why I am giving this extra information? Because suppose it is not isothermal and Tf, Ti values are also given, Cp values are given, then you can use this formula for entropy change calculation. This is a whole formula, but it is reduced to only Nr ln Pi by Pf, and the reason is because it is isothermal. And if you write it as PF to PI, this ratio, then there will be a negative sign here. So correct answer will be the second option, right? Correct thermodynamic conditions for the spontaneous reaction at all temperature. Spontaneous reaction means what? Del G must be 0. Now, if it is 0, then how we can get, sorry, it is less than 0, it should be negative. Now, how we can get it negative? For that, we need this relationship. Now, you want del G to be negative. That means this part must be positive. Now, T is always positive because it is a single value. That means del S should be positive. Then only this total term will be positive. And it is mentioned that at all temperature. So there is no mention of T in any of these options. Only del H and del S, whether they are negative or positive, that is given. Now, if you want del G to be negative, the whole quantity should be negative, right? So maximum what you can say, del H if it has to be negative, and del S that has to be positive. But somehow if del S is positive, sorry, if del S is negative, then negative will be positive. And in that case, del G may not be negative. Maybe negative, that depends on del H numerical value. But we'll see one by one what are these options are saying. Del H is positive. That means this, it is endothermic. Del S is negative. Now, if you put it in this equation, the whole quantity will be positive. So it cannot be correct. Then the second one is saying del H is negative, del S is positive. Now this may work. And remember, this question is basically conditions. So it is basically multiple correct choice. So multiple correct choice, more than one answer will be correct. So option B, that is del H negative, del S positive. So this will work. What about C? Del H is negative. Del S is also negative. So it will be positive, right? And the last one is del H is less than 0. That means it is negative. And del S is 0. Now that will also work. Why? Because now the second term is completely 0. And it is already mentioned as negative. That means obviously del G will be negative. Okay. So in this way, we can reach these two as the correct option. Fine. And it is also mentioned as, okay, spontaneous at all. Okay, fine. So B and D will be correct. We'll go to the next question. So it is mentioned as AIPMT. So previously NEET sometimes that is the same name is only different, but you can also consider it as NEET question. Okay. So enthalpy of combustion of carbon to CO2. That means you are reacting carbon and oxygen and you are getting CO2. So for this process, the energy released, because it is combustion, it will always be exothermic. Heat released is given. The heat released upon formation of 35.2 gram of CO2 from carbon and oxygen. Now, this amount is only for 1 mole. So when there is formation of 1 mole of CO2, starting from 1 mole carbon and 1 mole oxygen, then this amount will be released. But that is not true for 35.2. So what you have to do? This part you have to convert it to number of moles. So if you know the number of moles of CO2, then simply you have to multiply that number of moles with minus 393.5. Because this is only for 1 mole. So if there is more than 1 mole, or even if it is fraction, then we can get the answer. Now, to calculate number of moles, we need the molar mass of CO2. So 1 carbon, that means it is 12. 2 oxygen, that means it is 2 into 16. So it is 44. So this is the molar mass of CO2. This is the given mass. To get the number of moles, you have to divide this given mass with molar mass. Now it will be obviously fraction because 44 is larger than 35.2. So this is the number of moles, 0.8. So the answer will be something lesser than 393 because we are now multiplying this value which is only for 1 mole, but we need the answer for 0.8 moles. So it will be something some amount lesser than minus 393. So it is minus 314.8 kilojoule per mole. Unit will be same. So nearest value is last option, right? Next we'll go to, for the reaction X2O4 liquid, it is producing 2 moles of XO2, another oxide, but this is gaseous. Del U value is given as 2.1 kilocalorie. Del S is given 20 calorie. Again see, mostly as I have said, del S will be without kilo, but del H, del U, they will be in kilo. Kilocalorie or kilojoule. At 300 Kelvin, del G value you have to find. Now we know that del G is related to del H and T del S. So if you somehow know the value of del H, you know the temperature and entropy change, you can easily calculate del G. But in our case, del H is not given. But what is given? Del U. That means you have to find del H first. Starting from, you will find del H from what? You will find del H from del U by applying the relationship of del H and del U. Now for that you also need the del Ng. But del Ng you can calculate from this equation because total number of gaseous moles in the right hand side 2. What is the in the left hand side? There is no gaseous molecules. It is liquid. So del Ng value should be 2 minus 0. Okay. So we will use that equation, del H equal to del U and del Ng RT. So this is the equation. So del U we will put 2.1 kilocalorie. Del Ng we will put 2 because 2 minus 0 is 2. Now R value, be careful. Don't use 81314 because now you are doing the calculation in kilocalorie. All the answers are in kilocalorie. So we know R value in calorie unit it is 2. But that is not enough. You also have to divide it by 1000 because now from calorie, R value it is 2 calorie. But we need the value to kilocalorie. So that is why we are dividing it by 1000. Then the value of T. So you will get it 3.3 kilocalorie. Now you can use this equation because now you know del H, you know del S and T. So you'll use that equation. Del H is 3.3 which we have just calculated minus 300 which is temperature. Then del S again you have to convert the unit from calorie to kilocalorie. So that is why we are dividing 20 by 1000 and we are getting the answer minus 2.7 kilocalorie. Option 2. Five liters of a gas mixture, methane and propane. This is methane. This is propane, which is nothing but C3H8, right? Is perfectly combusted 0 degree centigrade, 1 atmosphere. So this is the STP condition. 16 liters of oxygen produced at the same temperature and pressure. Sorry, not produced, is consumed because you are doing combustion reaction. So there will be consumption of oxygen. 16 liters of oxygen consumed. You have to find the amount of heat released. Sorry, amount of heat released given. Amount of heat released given for methane del H comb, that is enthalpy of combustion is 890 kilojoule per mole, and for propane it is 2220 kilojoule per mole. But if you are thinking why there is no negative sign, because it is exothermic, negative sign is not there because it is already mentioned that the amount of heat released from this combustion. So as it is already mentioned, so there is no negative sign. Directly the numerical value is given, but actually it is negative. So for this reaction, the amount of heat released. Actually here, by mistake, I have not written the full question. In the final question, we just have to find what is the amount of methane. That is actually the question. Okay. amount of heat released from this combustion in kilojoule per mole is, somehow that is one line I have missed, but that is actually the answer. Okay. So we will start by writing the equation how methane reacts with oxygen during combustion. And here balancing the equation is very easy, because when you are treating methane with oxygen, as you have taken 1 mole methane, so obviously there will be 1 mole CO2 formation. As there is total 4 hydrogen, so obviously 2 moles of H2O will be produced. Now count the total number of oxygen atoms. It is 2 here and it is 2 here again. So that is why it will be 2O2. Okay. So now you have written this equation. Now the same equation you can also write for C3H8. So first I am writing simple oxygen. Then right hand side it will be 3CO2, because total 3 carbon. Total number of hydrogen 8. That means water molecule should be 4H2. Now to count the total oxygen. It is 3 into 2, 6. It is 4. That means total oxygen atoms will be 10. So I will put here 5. Now the total mixture. It is given as 5 liters. So suppose methane I have taken X liter. So this must be 5 minus X. You can also consider it as X liter for methane, Y liter for propane. That is another way to do. In that case, you will have to consider X plus Y as if it is 5. So one equation will be this, there will be another equation for oxygen. But I am doing it in this way. X liter out of 5 liters, suppose X liter is the value of methane volume. So 5 minus X liter should be the volume of propane. Now for X liter, you need the amount of oxygen, obviously 2X liter, because it is STP condition. So number of moles ratio, that will be equal to the volume ratio. So 5 minus X, and it should be 5 into 5 minus X, the liter of oxygen. Now you can write the equation for oxygen. Total number of oxygen consumed 2X, 5 into 5 minus X, and you know that value is 16. Now from this equation you can get the value of X. So if you solve this equation, you will see 3X is equal to 25 minus 16, so it will be 9. So X is basically 3 liter. Now if it is 3 liter, then the value of 5 minus X, that is actually 2 liter. Okay. So now you know the volume of both methane and propane. Actually, this the question is written properly. It is asking the amount of heat released from this combustion. That is the total amount of heat released. So the values of heat release that you are seeing, that is for individual reaction. Suppose you have taken only 1 mole methane. So in this reaction, there is this amount of energy is released, and this amount of energy is released for this equation. But it is asking the total amount of heat released. Sorry, it is not asking amount of methane, that by mistake I have said. It is actually asking the total amount of heat release. So next step what we will do, as we already know the individual volume of methane and propane, next we will find out the number of moles. So number of moles for methane will be 3 liter divided by 22.4 liter, because we know it is STP condition. So 22.4 liter is the volume of any 1 mole gas. So in this case, as you have 3 liter, so number of moles of methane that you can get by dividing its volume by 22.4. Similarly, you can also do it for propane, which is 2 divided by 22.4. So this is the number of moles for C3H8. So as you now individually know what is the number of moles of methane, multiply it with 890, and with it you have to multiply 220. Now this total quantity will give you the final answer. Final answer will be positive because it is already mentioned as heat released. So if you do the calculation, you will get 317.41, which is almost equal to 317. So that is why our correct answer will be the second option. Fine. 3 thermochemical equations are given below. The first equation is carbon graphite reacting with oxygen and it is producing CO2 gaseous. Del R value given. For the second reaction, again graphite, but now it is half oxygen. So instead of CO2, CO is produced. Third equation is carbon monoxide is reacting with oxygen, it is producing CO. Now from Hess's law, we can say that these three equations you can arrange in such a way. Suppose you are getting 3 by adding other two equations, or you are getting 2 by subtracting 1 for 3 or 3 from 1. So whatever it is, accordingly you can add del R H naught for all these reactions. That is the Hess's law. So based on this above equation, you have to find which relationship is correct. If you look at the equations properly, you will see if you add some reactions, you can get one reaction. So if you are adding, suppose we are adding 1 and 2 and 3. So when you adding these two, you will see these two are cancelled from both sides. C graphite will remain in the left hand side. Half oxygen, now it will be 1 oxygen. CO2 will be in the right hand side. So basically when you are adding 2 and 3, you are getting 1. That means y plus z should be equal to x. Another way also you can say that if I consider that when I am subtracting 2 from 1, you are subtracting 2 from 1, then also you can get equation 3. But subtracting 2 from 1, that means it is y minus x equal to z, which is another way of writing x equal to y plus z. So somehow you have to find the relationship, whether you add 2 and 3, you get 1, or you can subtract 2 from 1 from 2. So anyway, both will give you same result. So in this case, I have added equation 2 and 3, and you are getting directly the correct answer, which is option B. But you can also do the other way, that is, you can do equation 1 minus equation 2. So you will get equation 3, right? So C, sorry. So if you do so, then also you will get the correct answer. So in this case, we are subtracting 2 from 1, but both are giving same result. A reaction having equal energies of activation for forward and backward reaction, which of these will be correct? Now, if you consider energy profile diagram, so this is reaction progress and this is energy. Now, suppose this is the position for reactant. Now, I am just trying to say how to get del H value from energy profile diagram. So if it is reactant, this is activation energy, so this is the transition state, and suppose this is the position for P. Now here del H value is basically this gap. This gap is basically del H. So in this case, energy of P and energy of R, if you subtract, it will be a positive quantity. So in this case, it will be that is, this will give you the del H. But suppose if I am having both R and P at the same position, then what will happen? Del H will be negative. Now in this case, it is mentioned that activation energy for forward and backward. So in this case, this is the activation energy for the forward reaction, right? And if you consider the activation energy for the backward reaction, as if you have started from P, you are reaching R, then this should be your activation energy. So see here, activation energy for the backward process is greater than the initial forward activation energy. And in that case, there is some del H value. It is not 0. But del H 0 is possible only when activation energy for both the forward and backward are same. Then only it is possible. Okay. So that means for when activation energies are same for both the reaction, forward, backward, del H should be 0. So for a general reaction, remember del H is the activation energy for the forward reaction minus activation energy for the backward reaction. So if you are drawing it like this, so it is the activation energy for the forward, this is for the backward. So it will be exothermic reaction. So this will be the released amount of energy. But that is not in our case, because when these two are same, obviously del H will be 0. So this should be the correct option. And here, why the other options del G is not equal to 0? Because if it is so, reaction must be at equilibrium, but that is not mentioned here. So you cannot say that del G is 0, right? So only we can say del H is 0. So that is why this will be the correct option. Okay. One more problem. In which of the following reactions standard reaction entropy change is positive? Standard gives energy decreases sharply with increasing temperature. Now for del S not to be positive, you know del Ng must be positive. This difference. Now for the first reaction, this is 1 mole and in the left hand side you have half mole gas. So 1 minus half, it is basically positive del Ng. Now for this one you will see 1 minus or minus 1. This is negative. So here del S is not positive. You can cancel this option. Here also there is no gaseous. So this will again be negative. You can cancel it. Here we have half gaseous minus half. This is basically 0. So del Ng is 0. This is also not positive. So based on this also you can choose this option to be the correct option. That is the first option. So for entropy change to be positive, the moles of gases must increase, and for del H not to be negative, that is decreases sharply with increasing temperature, del H should be negative and T del S should be positive. Then only it can decrease sharply with increasing temperature. Now how to know del H is negative? See here the first reaction is basically combustion reaction, and combustion reaction del H is negative. Now you can say this is also combustion reaction. Then why we are not choosing it? We are not choosing it because here del S is not positive, which is another condition. So keeping both the points in mind, we will choose this option as the correct option. Okay. So we will end the session here. Thank you for listening.